In this video we're looking at the sum to infinity of a geometric series. So in a geometric series, if the common ratio is less than 1, the series is said to be convergent. Okay, convergent means that if we add up all the terms in it, it will get closer and closer to a specific number. It will have a limit. Okay, here's the formula for it. Again, A stands for the first term, R stands for common ratio. And this here, okay, it's kind of an 8 to the side. It's n. It's when n goes to infinity, we call it. Okay? Right. Here's an example. Find the sum to infinity of a half, a quarter, an 8, a 16, 32, 64. There's a kind of a legend to do with this special group of numbers. It's an Egyptian legend where one god, I think it was Seth or Thoth or something like that. But anyway, one god, the god of the sun, had a fight with the god of the moon. And one god took out the other god's eye, ripped it up and scattered it over the lands of Egypt. And he put a half of it in Cairo, and a quarter of it in the Nile, and an eighth of it in the west, and the 16th of it in the east, and 32nd of it in the northwest, and so on. So then that god's friend went around and tried to pick up all the pieces of the eye and put them back together again. And the question is, if the series goes on like this, a half, a quarter, an eighth, a 16th, as you can see, it's been divided, like been multiplied by a half the whole time. So the half turns into a quarter, turns into an 8, 16 to 32, 164, the next one will be 1 over 1 to 8. Okay? Will he ever get all of the eye? That's the question. And the answer is actually no. He'll get closer and closer to getting all of the eye, but he won't get all of the eye. Right? I'm going to use that story to just prove that he won't get all of the eye. So if I was to keep going on here, right? So keep going to 1 over 1 to 8, and keep going on and on and on and on forever, what number would I get very close to? Now I said, you should know this one already, I should get very, very close to 1, because he had one eye. Okay, so I get very, very close to 1, but I won't get there. Let's see, will I, when I put in all this information and get the sum to infinity of this series, will it give me back 1? So A is the first term, a half. Okay, I'm using this formula now. Over 1 minus the common ratio, which is half again, which equals a half over a half, which equals 1. And what that means is, if this series was to go on and on and on and on and on forever, I would get closer and closer and closer to 1, but I would never get there. Likewise with this one, find the sum to infinity of this. So if this was to go on and on and on forever, and I was to add up all these numbers forever, what number would it come closer and closer and closer to? Let's see. First thing is we have to find A, which is the first term, and the first term is 16. And common ratio is T2, which is 12, over T1, which is 16. And that will give us 3/4. Okay, so we have we have a formula is up here. So Sn, when n approaches infinity, equals A1 minus R. We slot in what we know. We know A is 16. I'll write this out. Goes to infinity. 1 minus R, which is 3/4. And that will give us 16 divided by 1/4. And 16 divided by 1/4 is 64. So if I was to add up all these terms forever and ever and ever and ever, I get 64. Okay. And that's it, guys.